Hello guys, and welcome to today's video, 155 min stack. So our problem is to design a stack that supports push, pop, top, and retrieving the minimum element in constant time. The methods that we're going to implement today will be min stack, the constructor. Basically, you have a push method which pushes the element onto the stack, pop, which removes the element on the top of the stack, top, which gets the top element of the stack, and get min, which retrieves the minimum element in the stack. And you have to implement the solution with O of 1 time complexity for each function. Okay, so taking a look at this problem, push, pop, and top should be relatively easy to implement in O of 1 time because you can just grab that element at the very top and manipulate it in any value, like in any way that you'd want it to do. The interesting part of this problem is the get min, because okay, like let's say like we're given a stack, right? Like we have like a stack like 1, 2, 3, or like 1, 2, 4, 5, right? It's easy to push and pop from the top of the stack, but the problem is when you want to get the minimum, let's say like in this case the minimum is 1. To get the minimum, you'd have to start at the top of the stack because the stack has a pointer to the very top of it, and you would have to traverse through every single element before getting that minimum if the minimum is at the bottom of the stack. So we have to try to figure out a way to get this to be O of 1 time. One way we could do this is, like the title of the problem says, we could use a min stack. So basically what we can do is we'll have a stack that's adjacent to the stack, which contains the minimum at that current point. So let's say we start off, we pop 1 to the stack, right? We pop 1. The minimum at this current point is 1, right? So we add that to the stack. Now, let's say like we add 2. Along with adding 2, what we can also do is add the minimum at that given point to the stack. So we'll have 1 because that's the minimum. Now, let's say like we have like a negative 1. So if we have a negative 1, that becomes a new minimum, and that's set as the like the top element in the min stack. With this stack and min stack, what we can do is basically whenever we want to push an element to the stack, we'll add to both of these. Whenever we want to pop it, we pop both of these, and for the top one, we can just grab the top one from the regular stack, and then from the minimum, you can grab the minimum from the min stack. So if that makes sense, I'll go ahead and begin implementing it now. Basically, the reason why this is O of 1 because you don't have to like go all the way down to the very end to check what the minimum is. You can just reference the adjacent or like the minimum stack. So yeah, first of all, let's go ahead and instantiate these two stacks in the constructor over here. So we'll do stealth.stack equals just a regular array, like a list, because in Python, a list can also be used as a implementation of a stack because it has its own pop and push methods. And then we'll have the same thing for this one, self dot min stack equals empty list. Now from here, we want to push a value. We're given a value here, so what we can do is do stack, self dot stack dot push. We can push or actually we can just append it. We can append the value to the stack, and then for the min stack, stack dot append, we want to check to see whether or not we're getting the maximum of, the maximum of the very last element in the minimum stack, so the most recent one. Basically min stack minus 1. If that value exists, if min stack, else we want that to be the maximum, or like our current value. And then want to get the max of this, and if the maximum is like the current value, or like the minimum is the current value anyway. Sorry, we'll do this. What we want to do is we would just want to like grab that value instead. So we can do the minimum of basically like the most recent element in that stack or the minimum of the current value, or the last element in the stack if it exists. Otherwise, you just want to compare it with val to compare it with itself. So that's the push method. What the pop method is going to be is you're going to basically just pop those elements from both of the stacks. So we'll do stack dot pop, and then also self dot stack dot pop. We're going to also do self dot min stack dot pop. So we're going to want to pop those two elements as well. For the top one, what we're going to want to do is we're going to just want to grab that latest element. So from the regular stack, so stack dot self dot stack dot we want to return that. Self dot stack dot pop, and then we want to return this. Return self dot stack dot the last elements in the stack, and then for the minimum we want to do the same thing, except for the min stack -1. So to go over this again, basically what we're doing is we're implementing two stacks, a stack and a min stack. For our push method, what we're doing is we're appending the current value to the regular stack. And then for this one, what we're doing is we're getting the minimum of our current value, or the latest element in the min stack if it exists. Otherwise, you want to be comparing it with the current value. So like if we compare the current value with the current value, it'll just have that as its initial, like as its value. So it'll work basically like what we were talking about earlier for that one. For the pop one, we're just going to be simply popping those two elements from the stack, and I won't return anything. For this one, what it's going to do is it's going to get the top element from the stack, and same thing for this one, it's going to get the top element from the minimum of the stack. So if you go ahead and run this, go ahead and fix that typo. Oh, right. Okay, you know what? Let's go ahead and check to see if there's any other similar errors like that. So we go check this, self, min, val. Yeah, I think that should be it. If you go ahead and run it again. Okay, great. So it works with those two test cases. We'll go ahead and do a submission just to make sure. And yep, it's accepted. Nice. So also one thing to note is that the constraint is that the operations will always occur on non-empty stack. So like you assume that the stack is populated. If you want to watch out for that edge case where those items in the stack are not populated, then we're going to want to surround these return values in like an if statement or something similar to that in order to make sure that it's a non-empty value. So yeah, that's it for now. This way everything is an O(1) operation, and get min is also an O(1) operation because of those two things. Yeah, like we could go further with it and implement a stack ourselves, especially for like this. Instead of initializing it with Python's default implementation of a stack, we could create our own one. But I think that might be good content for another video instead. But yeah, thank you for watching.